Hello everyone, myself Sridhar and I'm from CSAF section. And for the AT Tech Talk, my top for the subject DBMS, Database Management System, my topic is about a bandwidth, link resources, cooperative allocation strategy of data communication in intelligent trans. Here, let's go with the introduction to data communication in intelligent transportation. Intelligent Transportation System ITS rely heavily on efficient data communication for real-time decision making. The increasing demand for bandwidth necessitates innovative resource allocation strategies. Cooperative bandwidth link resource management can enhance overall system performance and readability. Here we can see the key components of resource allocation are the people, budget, data information, time, and also tools and technologies. Here, the intelligent transportation system ITS rely heavily on the data communication for real-time decision making, and also the cooperative bandwidth resources management can enhance overall system performance and reliability. Challenges in data communication for intelligent transportation: limited bandwidth and dynamic network condition pose significant challenges. Here, the high mobility of vehicles causes frequent changes in network topology, ensuring quality of secure services while optimizing resource utilization is complex. Here, these are the challenges in data communication for intelligent transportation, where the limited bandwidth and dynamic network composition are like having the high mobility for vehicles and so causes frequent changes in the network topology. And also, the overview of bandwidth link resources. Here, the bandwidth refers to the data transfer capacity of communication links. Link resources include not just a bandwidth with also latency, stability, and also reliability. Efficient management of these resources is critical for seamless data exchange. Here, the bandwidth refers to the data transfer capacity of communication links. Link resources includes not just only bandwidth and also it is a latency and stability and reliability is the most important factors for any bandwidth resources. The cooperative resource allocation concept. The corporation involves multiple node sharing and coordinating resources usage. It aims to optimize the overall network performance rather than individual link efficiency. The cooperative strategies can adapt to real-time network condition for better resource utilization. Here we can see that the corporate resource allocation concept is basically the concept where we're having a multiple node sharing and coordinating resource usage. This multiple node sharing and coordinating resource usage is mostly aims to optimize the overall network performance rather than the individual link efficiency. And also these cooperative strategies are like adaptive for the real-time network condition for the better utilization of the resources. Existing strategies and their limitations. Here, the traditional allocation methods often prioritize individual link performances, such as these methods may lead to resource underutilization or congestion. Existing strategies lack adaptability in highly dynamic vehicular environments. Here we can see that these existing strategies are traditionally allocation methods which are like prioritized only for the individual link performances. These methods can only lead to the resource utilization and conjunctions. Uh, Proposed cooperative allocation strategy overview. The proposed strategy dynamically allocates bandwidth link resources based on network needs. It incorporates cooperative algorithms that enable nodes to share information. The approach aims to balance load, reduce latency, and improve data throughput. Here, this proposed the strategy is the most important strategy where we have the optimal allocation, which is the capital allocation on the top where and under it we're having organic growth needs, and then we do have free cash flow, and then we do have an investment in M&S, and also competitive dividends and the share pension. These are the allocation strategy overview for any bandwidth network. Algorithm design and framework. The strategy employs a distributed algorithm with local decision-making capabilities. It uses real-time data exchange among nodes and to access network condition. The framework includes priority assignment, resource negotiation, and adjustment phases. In this algorithm design, mostly the design is basically having some flow within local decision-making capabilities and also the real-time exchange among the nodes and the access network conditions. Here the resource sharing mechanism, the most important thing about the resource sharing mechanism is to nodes collaboratively determine their resource requirement and sharing potential. A negotiation protocol ensures fair and efficient distribution of band. This mechanism adapts to changing network topology and traffic conditions. Here, the joint selection of local trainers under the resource allocation for federated learning in Open RAN intelligent controllers. Here, the nodes collaboratively determine the resource requirements and also the sharing potentials. And then we go for the optimization objectives. Here, the maximize overall network throughput and data delivery reliability. Minimize latency and packet loss during data transmission. Ensure fair resource distribution among all participating nodes. Here we can see that the optimization objectives are to maximize overall network throughput, which is the time taken for all the operations and the data delivery reliability. Here the data reliable on everything. The optimization is most important for these reliability, such that it could happen have it in flow and the having a delivery and with a reliable fashion. And the minimizing the latency and packet loss during the data transmission. The minimizing the latency, which is the latency is nothing but the time which is taken for the optimization or the time which is like taken for the optimizing the bandwidth, where if the latency is less, it means the bandwidth having a good performance, and the packet loss during the data transmission is also has to minimize it to get a optimization better optimization. Ensure fair resource distribution among all participating nodes. All the nodes should have the fair distribution, which cause this in this there should be a fair decision making. Simulation and performance evaluation. The strategy was tested using simulated vehicular network scenarios. Result demonstrated improved bandwidth utilization and reduced communication delays. The cooperative approach outperformed traditional allocation schemes in key metrics. Here we can see such metrics such as here we can see those things where we do have some things where the strategy was tested, such as simulated vehicular network scenarios. This resulted in demonstrating the improved bandwidth utilization and also reduced the communication delays. This cooperative approach outperformed traditional allocation schemes in key metrics. And then we go for benefits of cooperative allocation strategy: enhanced network stability and robustness in dynamic environments, better utilization of limited bandwidth resources, increased data transmission efficiency, supporting intelligent transportation applications. These are the benefits of the cooperative allocation strategy, where the most important the benefit is to enhance the network stability and the robustness in dynamic environments, and also better utilization of limited bandwidth resources, and also the increases the data transmission efficiency and supporting intelligent transportation applications. Practical implementation consideration. Implementation requires real-time communication protocols among vehicles and infrastructure. Compatibility with existing vehicular network standards is most essential. The scalability and security aspects must be addressed for widespread adoption. Here, the practical implementations where the implementation requires the real-time communication with the protocols among the vehicles and the infrastructure, and also the compatibility in vehicular network standards is essential. The scalability and the security must be addressed for the widespread adoption. Future research direction, integration of machine learning techniques for predictive resource management, exploration of cross-layer optimization strategies, development of adaptive algorithms for emerging 5G and beyond networks. Here are some of the things such as integration of the machine learning, whether the most important for the predictive the resource management and exploring the cross-layer optimization strategies, and also it is helps in emerging development of the adaptive algorithm for emerging 5G and beyond networks. The conclusion, the final conclusion is to the cooperative bandwidth link resource allocation is most vital for efficient, intelligent transportation of the data communication, and the proposed strategy offer uh, adaptive, fair, and other optimized resource management. Continued research and development can further enhances ITS performance and safety. Here, the resource allocation is it's a group of analysis, analytics, timelines for the tracking, allocation itself, estimation, etc. And this is all about the bandwidth resource allocation. Uh, and this is all about the bandwidth resource allocation. Thank you.